Hey Professor, this is Carl Crook, a student of CSA 380 undergrad, and I'm going to demonstrate my min-max algorithm. I'm going to run it. First it's going to ask for a file. Let's do test case 1. This part, -1, if you want to evaluate the whole tree. Give you solution. Let's run again. Let's say test case 2. Let's say we want to evaluate the trees to a depth of 2. Okay, well, let's do it one more. Let's say now we go to a depth of 4. And there you go. I explained the rationale behind this in my written response. So the way I modeled my dance battle is a class called board. In my class board, I represent the dance battle as a 2-dimensional Boolean array, which is this variable right here. And then also I have an array that says how many moves are left per row and column. And then also I have the board's value, which will be used in the min-max algorithm. Those 4 variables are basically the important ones that are used in the actual algorithm. And then one more thing, there's also I have a lot of functions like make the move and if the move's legal. But the big one is this constructor right here, which takes, oh no, that's the wrong one. It's this one. It takes a board and then a move, which will return an updated board. And this is important because, okay, it does all of its computations. And in this constructor, it's where it calculates the value for that board, which will be used in the min-max algorithm. Such as, you know, if it's a game over, it sets its value to positive or negative infinity, or it calculates some other value, which will be used in the min-max algorithm. Alright, now for the actual min-max algorithm. There's a file called min-max class over here. The main variables, the main things to look for is this variable called t. It's a tree data structure, which I defined in my tree class. It's just basically a tree where the nodes are a board, an array of children, and a pointer to the parent. And then also this back in min-max our solve function, which is the actual min-max algorithm. Going here, when we invoke the constructor, it's going to automatically run solve to the depth we specified in our input, our console input. When we go to solve, it's basically a while loop. While we did not find a path, an optimal path, we build a tree to the depth we specified, and then we run this function called solve helper, which is a recursive function. It's down here. That's basically backs up the correct values we need to make the best move. So if it's max's choice, it's going to choose the max of its children. If it's min, it's going to choose the min of its children. You know, like the way it does it to back up the values correctly. And it does it recursively. And then what we have, I passed it. We store the value here, our best value, and then what we do with the value is in this loop we locate the child that contains that value. When we go back to our board, there's a variable here called best value, which is where it sort of gets saved as it's computed for each board. And then we find the board back in min-max, we find the board that has that value, and then we update the board min-max is using to the child board, and then it just basically keeps going through this while loop until it finally reaches a solution, which is determined here. Once the root of the tree doesn't have any children, that means we found some sort of solution. It breaks the while loop, and then we print out the path, and then if we won or not. Just as a quick thing, if you need more help in understanding what's happening, I left this little commented code here. If you want to comment it and then run the program again, as each time the tree is built, it's going to print out the tree for you into the console window in a depth order manner if you want to see more of what's happening.